today's topic is ionization energy or ionization potential or ionization enthalpy. This we can represent it by delta IH or IE. The unit to represent the ionization energy is kilojoule per mole. What is the ionization energy? As when we remove an electron from an isolated gaseous atom, it required some amount of energy. So the energy required to remove an electron from an isolated gaseous atom of an element is known as ionization energy. When an atom loses one electron, its ionization energy we can represent as IE1. When the monovalent atom removes the second electron, the ionization energy is known as IE2 or second ionization energy and form the M+2 type of ion. When the third electron is removed from the divalent ion as M+2, the ionization energy is represented by IE3 and M+3 type of ion is formed by removing of one electron. The third ionization energy is more than the second ionization energy, which is more than the first ionization energy, because when the first electron is removed from an atom, it requires some amount of energy. When the second electron removed, then the number of proton in the atom is more than number of electron. So the per electron nuclear charge is more. That's why to remove the next electron is difficult and it requires more energy. And again, when we have to remove the third electron from the divalent ion, it has more attraction of the nuclear charge towards per electron, or the effect of nucleons per electron is more. That's why the third ionization potential or ionization energy is higher than the second ionization energy. But it is more difficult to remove the electron from the divalent ion. Now, some factors on which ionization energy depends. Let us study these factors on which ionization energy depends. First is atomic size. As the atomic size increases, so the electrons are far from the nucleus. As electrons are far from the nucleus means they feel less nuclear charge or nuclear attraction. That's why the ionization energy decreases with the increase in size. As the size increases, ionization potential decreases. As the size decreases, ionization potential increases. Nuclear charge. More the nuclear charge in an atom, more effective is the nuclear charge per electron and more the ionization energy. So ionization energy increases with increase in the nuclear charge. Next is screening effect or shielding effect. What are these effects? As in multi-electronic atoms, where many electrons are present, the differentiating electrons or the electron which is present in the valence shell, which we have to remove, are far from the nucleus. Many electrons are present between the nucleon or nucleus and the outermost valence shell electron. These electrons which are present in between the nucleus and outermost valence shell electron act as a shield for the valence shell electron, which decrease the effect of nucleus towards the valence shell electron and known as screening effect or shielding effect. And because of this effect, ionization energy decreases with increase in the inner electron, or as the shielding effect increases, ionization energy decreases. That's why down the group ionization potential decreases. Penetration effect of the electron, as according to the wave mechanical model, the electron clouds of various electrons don't maintain their distinct boundary. They are penetrating to each other. Penetration power of the s orbital electron is more than p orbital electron, which is more than d and the f block electron. So, for the same value of principal quantum number n, if the electron or valence electron is present in s shell, the ionization energy for s electron is greater than the p electron, which is greater than the d electron, which is greater than the f electron. Means if for the same energy level, if the electrons are present in n orbital, then they feel the more penetration power or attraction towards the nucleus, hence they have the more ionization potential. Fifth factor is the electronic configuration. As you know that half-filled or full-filled orbitals are more stable. Like in case of nitrogen 7 electrons, p orbital 2 and 5, where 2s, 1s2, 2s2, 2p3. So p orbital is half filled in case of nitrogen. In case of noble gases, p orbital is completely filled. Half filled or full filled orbital causes extra instability, and because of this they have the higher value of ionization potential. That's why in the period noble gases have maximum ionization potential. Means they are not allowed the electron to remove from the atoms. They have the stability. Now, with some examples, we have to explain this ionization potential. First, variation in ionization, general trend of the variation of ionization potential in the periodic table. As we move from left hand side to right hand side in a periodic table, from S block to P block, the ionization potential increases. So, increase across the period of moving left to right, and decreases down the group as the atomic size increases down the group. So, that's why the ionization potential decreases down the group. Now, with some examples, I am going to explain this ionization potential. Now, here are some examples in which we have to find out which element would have more ionization potential. First ionization potential. As first case, beryllium and boron. Electronic configuration of beryllium is 1s2 and 2s2, and for boron as atomic number 5, it has an atomic configuration 1s2, 2s2, 2p1. So here in case of beryllium, the electrons second s orbital is completely filled, and s orbital is more penetrating than the p orbital. And third thing, that barium has more ionization potential than boron is that s orbital is nearer to the nucleus and there is no shielding effect, as s orbital is nearest to the nucleus, and when the electrons are in the p orbital, s orbital electrons act as the shielded electrons. That's why the boron, the first ionization potential in case of beryllium is more than in case of boron. Now, in case of nitrogen and oxygen, as in case of nitrogen, the electrons are filled in p orbital as 2p3, and in case of oxygen, it as electronic configuration is 2s2 2p4. We know that half-fill orbital causes extra stability. In the case of nitrogen, the p orbital is half-filled. That's why nitrogen has more first ionization potential than the oxygen, first ionization potential of oxygen. Now, in case of chlorine and fluorine both are present in the same period. Fluorine has more atomic number than the, chlorine and fluorine. So they are present in the halogen family or 17 group elements. Fluorine is present above the chlorine. As we know that down the group ionization potential decreases. So the ionization potential of first ionization potential of fluorine is more than first ionization potential of chlorine, because chlorine, the some electrons act as a shielding electrons, and that's why the bond shell also increase as we move down the group. That's why first ionization here, the fluorine size is very small. That's why fluorine atom has first ionization potential more than chlorine atom. Now chlorine and sulfur. Sulfur has atomic number 16 and chlorine has atomic number 17. Means they are present in the same period, 16 and 17. So the size of the chlorine atom is smaller than the size of the sulfur atom. As we move from left to right in a periodic table, the size decrease, number of nucleon also increase, and effective nuclear charge per electrons also increase. That's why size of the atom decreases, and that's why sulfur has less ionization potential, means chlorine has more ionization energy than the sulfur. Chlorine has more ionization energy because of the smaller size of the chlorine atom. Now next case is potassium and argon. They both are the noble gas. Potassium and argon. Potassium atomic number 19. They are not noble gas, and argon is the atomic number 18. This is the noble gas. And argon is present in the third period and potassium is present in the fourth period. So because potassium, because of the stability, view of the stability, because argon has the stable electronic configuration, that's why it has more ionization potential than in the case of potassium atom. Because of stable electronic configuration, first ionization potential of argon is more than first ionization potential of potassium, or in another word, potassium has lower ionization potential than the argon. Now, krypton and xenon. Krypton and xenon both are the noble gases which are present in the same group. Helium, neon, argon, krypton and xenon. We know that down the group ionization potential decreases. Ionization energy decreases down the group. That's why chromium first ionization energy is more than first ionization energy of xenon. Now the next question is, among these elements, which of the element is likely to have a reactive metal, a reactive non-metal, a noble gas, a metal that form binary halide of formula AX2 type? Now, a reactive metal means the metal which have lower value of first ionization potential and higher value of second ionization, much higher value of second ionization potential. So among these all elements, second element has less value of first ionization potential and much higher value of second ionization potential. That's why the second element is the reactive metals. Now a reactive non-metal. Non-metal is present on the right hand side of the periodic table. So right hand side of the periodic table, the element having high ionization potential. So the non-metals are the element which having more value of first ionization potential and still much higher value of the second ionization potential. Both value are higher. It means among these we can see the 16, 18. These two elements having the much higher value of first ionization potential and the second ionization potential value is also higher, but here the noble gas is also present. So noble gas, because of the stability, it has much higher value of first ionization potential than the non-metal. That's why fourth element is a reactive non-metal and first element is a noble gas. Fourth element is the reactive non-metal and first element, which have both the ionization potential higher value, is the noble gas. Now next is the last, a metal that form binary halide formula AX2. Binary halide has the group 2 member which have comparatively higher value of first ionization potential and also much higher value of the second ionization potential. So third is the element which have 900 kilojoule per mole value of first ionization potential and 1760 is the kilojoule per mole is the second ionization potential. So it is the binary matter. So this is all for today. Now next you will study the electron gain and enthalpy. Thank you and have a nice day.